Hey everyone. In my last video I showed you how I got my AI to avoid flying into the large ships, but I ran out of time and I didn't get to show you how the camera avoids clipping into those large ships. So here's how that works. And so I've created a camera system that allows essentially sliding the camera closer to the ship when it's colliding with stuff. And so if I do a little spin on top of this carrier, you can see that the camera will not allow us to clip inside of the ship anymore. As I start looking up, so there is still some tweaking that needs to be done because, as you can see, it is still possible to clip. In not all scenarios does it clip, but there seems to be some. So I think I need to create a larger collision on the camera to avoid the clipping. So as you can see right there, it's not clipping. And so I think this camera algorithm is rather interesting, so I'll spend a few seconds talking about it. So this is how the camera collision essentially works. Well, let me start by showing the process that I went through. So the first thing I thought of was like, okay, we have a ship that we're controlling. We have this camera that is behind it, looking at it. And it's kind of following it on this boom. So when you were turning past a ship, like the large carrier, part of that carrier's collision, draw it red, could have been, the camera could have been inside of it. And so what I wanted was to move this camera right here. So the first thing I attempted was, let's put a collision box on the camera. The collision box will give you a minimum translation vector due to separating axis theorem, which means it says, hey, if you take that vector and follow it and slide to right here, you're not going to be in collision anymore. So I did the collision test, got the minimum translation vector, and then obviously if we move the camera up here, it's not going to be pointing at the ship anymore. It's going to be looking in the wrong direction. So what I did is I took the minimum translation vector and projected it to this vector. So now we move the camera here. The problem is that doesn't always happen. It doesn't always happen that the minimum translation vector will do that. It will do that in some cases, but in other cases, consider, for example, when we have the collision box right here. If we have a collision on the camera, the minimum translation vector actually takes us out this way. It says, you're colliding here, move this way, and restation yourself that way. And so I would project it onto this vector and end up putting the camera behind the actual carrier collision, which is this red box. So that didn't work. The next thing I thought is, well, okay, what we'll do is we will put a collision box around the camera. And let's just draw this carrier ship here again. So we did put a collision box around the camera, but we only want to project, we only want it to slide towards the ship. So what we can do is say, all right, did it collide? If it did collide, what we'll do is we'll take this vector to the ship, or we'll make this a vector to the ship in the first place. So let's generate a yellow vector that says from the camera to the ship. We have this known vector. Now, if there's a collision, what we will do is we will go halfway halfway along this vector and try here. What if we collide here? Do we collide or do we not collide? And so in this case, when we move the collision box here, we are no longer colliding with this shape. So this is good. But we don't want the camera to slide this far up. We actually want the camera more around this area. So the next step is to search in this range. What we'll do is we'll take the halfway point. So let's get rid of that collision box. And now we're on this range here, so we'll take the halfway point there and we'll try a collision box here. And let's say that the collision box is this size. All right, actually, yeah, we'll just make it here. So at the midpoint, yes, it did still collide. So what we do now is we switch to this range and go halfway point here, collision box, no collision. Repeat the algorithm again, halfway here, collision box, no collision. And so this is basically a binary search. And what I did is I implemented this with some limited number of steps. However, that worked in most cases, but it had other problems. And those other problems being, what if you had a collision box or a carrier collision like this? And so the camera has its collision and the carrier has its collision here, but they never are colliding. So your camera stays behind the carrier ship and you don't get any updates. So the resolve for this is to not use a collision box on the camera, but use a collision box that is along that vector towards the ship and the camera. And so now when we have, if we have this carrier collision, we test, is this box colliding? Yes, it is. So we also make sure we generate that same vector to the ship. And since it is colliding from here, we now say, okay, go to the middle and let's generate a collision box here. So this is going from the new theoretical camera position to the ship. Does that collide? No, it doesn't. So what we do is we take one more binary search and step, and we generate a new collision box from there to there. Does that collide? No, it doesn't. So what we do again is half that. And oops, I think I made it that one. Either way, you half it, no collide, half it again, and then we get a little bit of collision. So now we go the other direction and try here, and then we try here, and then we try here, and we eventually get very close to where it should be. I defined it currently at 8 iterations. I did not test, but I think I could do with even less iterations. And so that's how the camera finds its new position. When it does clip, I think it's because I need to extend the back portion of the camera a little further. So like instead of making the back right there, make the back of it right there, and that'll help avoid any extra clipping. But that's it. So I made some tweaks to the camera and it seems to be working even better now. So I also improved the collision boxes of the actual carriers, because in the previous video you could see that the ship would clip into the actual carrier a little ways before it would collide. And so now I've made those collision shapes very close to the actual shape of the carrier, which gives better collision. So I think the next steps are to create little components on the ships that you have to destroy before destroying the actual ship, before you can actually destroy the ship. So like maybe gun turrets and satellites and generators, things like that. That way you have some sort of objectives that you have to complete in order to take down one of these large carriers, instead of just having it blow up like that.